Hi, this is Brandon Baines in the Math Department at Lipscomb University, here to talk to you about counting the number of arrangements of a collection of objects. In this app, you'll learn how to count the number of arrangements or orderings of a collection of objects. One example of doing this might be to count the number of ways that a basketball tournament can finish with places 1st through 8th when there are 8 teams in the basketball tournament. We'll also learn how to count the number of arrangements or orderings of a certain size from a collection of objects. So this is the case where we're going to arrange a subset of our collection. And so if we had the 8-team basketball tournament, we might be interested in how many ways the 1st through 3rd place could end up. These are called permutations. A permutation is an ordered arrangement of a collection of objects. One key aspect to permutations is that we're talking about things that have an order to them. And so when we change the order of the objects that we're counting, then that changes the outcome. We consider that to be different. Thinking about the basketball tournament example, we would consider the Lakers coming in 1st place, Warriors in 2nd, and Cavs in 3rd. We would consider that to be a different outcome than Warriors in 1st place, Lakers in 2nd place, and Cavs in 3rd. And in fact, we could come up with several other arrangements of these 3 teams that we would consider to be different. For example, what if the Cavs came in 1st place? Let's look at an example. A club with 12 members is going to be seated together at a concert. How many different ways can they sit together? Well, the fundamental counting principle will still help us solve this problem. The number of ways is 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That calculation again comes from the fundamental counting principle, where the number of ways that the first seat can be taken is 12, because there are 12 members. But once that seat is filled, there's only 11 ways that the second seat can be filled, and so on. That ends up being quite a large number, 479,001,600 ways. That calculation we did, multiplying 12 all the way down to 1, is known as 12 factorial, or in general, n factorial for any given number. N factorial is defined to be n times n minus 1 times n minus 2 times n minus 3, and so on, all the way until we get down to multiplying by 1. When we do factorials, 0 factorial is defined to be 1. N factorial is always representative of the number of arrangements or permutations of n objects. So if you have 13 trophies that you want to arrange, then there are 13 factorial ways of arranging those. Let's get a little comfortable with calculating factorials. We'll look at 8 factorial first. Just using the definition of factorial, we're going to multiply 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That results in 40,320. Occasionally we'll come across calculations that require us to divide 2 factorials, like 4 factorial divided by 2 factorial. Word of caution here, consider your order of operations on these. A lot of students will want to divide first here. They'd want to call it 2 factorial, thinking about 4 divided by 2. That actually violates order of operations. So first we must execute 4 factorial, and you'll see that we've done that 4 times 3 times 2 times 1. And we must execute the command 2 factorial, which is 2 times 1. From there, we can divide common factors. That results in 4 times 3. and 4 times 3 is 12. Looking at n minus 1 factorial divided by n factorial, we'll do the same thing. Execute the command of n minus 1 factorial. And you'll see that's n minus 1 times n minus 2 times n minus 3. We'll continue going until we multiply by 1. Execute the command for n factorial. That's n times n minus 1, so on until we get down to multiplying by 1. There happens to be a lot of common factors here. N minus 1 divided by n minus 1, n minus 2 divided by n minus 2, and so on. And so our numerator is actually all of those factors divide to equal 1 with other factors here. So it's just 1 over n. Let's consider the same club that had 12 members. But now they're going to select their president, vice president, secretary, and treasurer. We might be interested in knowing how many ways that they can elect these officers. We can use the fundamental counting principle to solve this problem as well. There are 4 events here, selecting president, vice president, secretary, and treasurer. And so there are 12 ways that we could select someone to the president office, or whichever office is selected first. Whoever is president will likely not be the vice president, so there's 11 people left to be elected vice president, and so on. That results in 11,880 ways. Example 3 is what we call a permutation or an ordering of n objects r at a time. In that case, we had 12 people that we were ordering 4 at a time because there were 4 offices that we were electing people to. There's a formula for evaluating this NPR, this n objects arranged r at a time. It's n factorial divided by n minus r factorial. We will note that we were able to solve that problem using the fundamental counting principle. So in a lot of our problems, the formula here is not a must, but it is handy to have. So looking at the previous example, we would have 12 objects arranged 4 at a time using the formula. Would be 12 factorial over 12 minus 4 factorial, which is 12 factorial over 8 factorial, and then executing the commands of factorial and dividing common factors, we still get 11,880 ways. Let's take a look at one more example. There are 8 teams in a basketball tournament. How many ways can the tournament end with places 1st through 8th? And then 1st through 3rd. This is like we started the presentation with. So in solution A, we're ordering all of the objects. There are 8 factorial ways, which turns out to be 40,320 ways. In part B, we're ordering the 8 objects 3 at a time. So there are 12 objects arranged 3 at a time. And using the formula, we would have 12 factorial over 12 minus 3 factorial. Using the definition of factorial and simplifying, we have 1,320 ways.